So I'm still in student mode. Don't worry about it. The only thing is, I don't like how this auto plays when I start the activity, and since I'm wearing headphones, it's very loud. But this unit's going to be about sine, cosine, and complementary angles. I kind of talked about this at the end of the last one, but the general idea is that the two opposite angles are complementary, meaning they both equal 90. And we'll get into that in a little bit. In this lesson, you will explain the use of relationships between sine and cosine of complementary angles. So, complementary, if you guys don't remember, oh, and also, as always, you guys can always print out the guided notes to help you with this. Uh, Remember, this is opposite and adjacent sides. This, I think, just really helps you out when you're taking the test. So if you need this, I do recommend it. It really helps out for the mastery test. But our objective here will be to learn the relationship. So you kind of need to know what complementary means if that's part of the objective, right? So if we remember supplementary, we've used this a lot. Supplementary means adds up to 180. Oops, I forgot an A here. Means adds to 180. Well, complementary is kind of the same idea. Complementary. Except this time it means adds to 90 degrees. And this is relevant because think about it this way. A triangle is supplementary, right? A triangle adds up to 180. But let's say one of these angles is already 90. Well, that means these two last angles have to both be 90 no matter what. If this is 90 degrees, we only have 90 degrees between these two angles left. So let's get into how that's going to relate to sine and cosine. All right, so we know that sine is opposite over hypotenuse because of SOHCAHTOA. Cosine is going to be the adjacent. So just to write them in, so this is the opposite of the angle. And then this one is the adjacent. So this is our angle, and this is the hypotenuse. Well, let's say we were talking about the other angle. Let's say we were talking about this angle right here. Let me do a better color. You can barely see that. So this would now be the opposite of the red angle, and this would be the adjacent of that angle. This is still the hypotenuse. So it's the hypotenuse for both of them. They kind of switch sides when we talk about the other one. So this is just going to be the introduction, kind of refreshing you on SOHCAHTOA, the video I did right before this one. So when we're talking about this, these angles, they add up to 180. So this is just a vision. If we took these together, pull out the calculator. If I did, for example, if I did these two, 24 plus 66, it equals 90. And then if we add that other right triangle, it equals the 180 that I was talking about. That's what we're doing here. We're just adding these angles together. All right, so let's go into the next one. Let's go into our unit activity, actually, or the lesson activity. Sorry. So right here, measure these angles. All right, so let's go into our activity. And I don't know why. Oh, they don't show it yet. All right, so we won't bother with these yet. So let's measure our angles. I was like, on the last one, they usually gave us our angles. This one we have to do it. Remember, we always want to go counterclockwise. So if we want measurement of angle A, we want to go from C to B because we're going counterclockwise. So we're going to go C, A, B. Now, if we want angle B, we're going counterclockwise. That means we want to go from A to C. If we go from C to A, we're going to end up measuring this outside angle. So we're going to want to go A, B, C. Cool. So we get this 22.62 22.62, and we're going to get 67.38. 67.38. If we added these two up, they would equal 90. Now they want us to measure um, the sides. So just to make this quick, I'm just going to touch the sides. So I just touched that. We got 5 as the opposite of A, 12 is adjacent to A, and 13 is the hypotenuse of this triangle. So AB is 13, so our hypotenuse is 13. BC is the opposite of A. I used to know how to do these really well. This is obviously the opposite. I don't know how to remember the adjacent and the hypotenuse, but this is the opposite because it doesn't include A, and it's in a triangle, so obviously this has to be the opposite. So that's 5 and 12. There's no easy trick for these. You kind of have to look at the triangle to figure out those. Now we want to use sine of these angles. It says use GeoGebra, so that's nice of them. So we're going to go on here. We're going to click. We're doing sine. So let's show the sine and cosine of A. We're only doing A right now. So we're going to go all across and do this. So according to GeoGebra, the sine of A is 0.38. So we get this fraction 0.38. Now we want to use a, no, oh, got ahead of myself. Now we want to do cosine, which is 0.92. We want to use a calculator. Well, we're going to have to grab this angle. So I'm just going to copy it. I forget, you can't copy here. Control C. And we're going to pull out this calculator. And you can just clear this out. And Control V. Oh, it didn't plug it in. Darn. Well, looks like you can't copy and paste your way here. Weird. 22.62. We'll scroll down and we want to find, with the calculator, we want to find the sine. So when we type in sine, we get that 0.38 also. 0.385. Just to be a little more specific. 0.3846. Now we want to do the cosine of the other angle, so we're going to clear this, and we're going to do, what is it? The angle is 22.62. So we're going to do 22.62, push the little cosine button, and we get 0.923. Now we're going to do the other angle. So according to GeoGebra, the other angle should be 0.92. So this is 0.92, which kind of looks like the cosine of the other one, right? Now when we do sine, or when we do the cosine, that kind of looks like the sine of angle A, which I know is kind of the point of this exercise, but just to point it out. And we're dealing with 67.38. We're going to hit that cosine button. So basically, this calculator is just a little more specific. Oh, I meant to do the sine button. Well, might as well fill in the cosine button while we're here. 0.3846. And then I'm going to clear this. What was it? 66.38. And now I'm going to remember to actually hit the sine button. And that's going to be this 0.9162. So if we look here, it's a little off, right? It's a little bit. There's some calculator errors. And there's probably some round off error with this angle here. But for the most part, they're pretty close, right? Show sine angles of this. So we're going to do it for all of these. So, so if this is 14 or 15, then this angle Let me clear this out because I can't. A little early in the morning for me to figure that out right now. That's 75. And then if this is 30, this has to be 60. And if this is 45, well, then this one has to be 45. And if this is 60, then this has to be 30. And if this is 75, well, we already know the complement of that is going to be 15. So this is 15. All right, and now we're going to do the sine. What I recommend doing, since we know they're going to be opposites of each other, just go down this way and it'll end up going the other way too. So we'll see that. So let's do this one at a time. Might as well use the calculator because it's here. That way I don't have to go back and forth and change angles on GeoGebra. That sounds terrible to me. So we're going to do 15 and we're going to do cosine and we're going to get this 0.966. I'm just going to do 3 decimal places just to make this faster. Clear this out. Then we do 30 of sine. We get 0.5. Clear this out. Then we're going to do 45 of sine. We get 0.707. This is why, if you remember from the last video, I put 0.71 because I knew it was going to be 0.707. It's just something learned when you learn about unit circles in Algebra 2. And then we're going to do 60, and we're going to take the sine of this, and that's going to be 0.866. And then finally, we're going to do sine of 75. We're going to take the sine of that, and we get 0.966. We rounded it. Look at this. See, we kind of went full circle here. I feel like I'm missing something. Did I do the wrong one for one of them? Give me a second. 75. We're gonna do sine. That one's right. 15 sine. Oops. Totally did the wrong one. That was kind of throwing me off a little bit there. I was a little confused at how we went from like 0.9 and we dropped that far. So here we can see a gradual increase. Now, let's take a look at this. This is kind of interesting. Let's say we do 15 and we do the cosine. That looks a lot like this one. And we already know that the sine of this is going to be the cosine of this one. So I'm just going to put that in now. We already proved that with the last one. And if you guys don't believe me, I'll just do it right now. I'd rather show you guys a little bit of work to complete this a lot faster. Hit the cosine button. And actually, we know that because I hit the wrong button by mistake. When I hit the 15, I hit the cosine button. So we already knew that. So basically, this should match up with this one because 30 and 60 equal to that. All right, so what we're going to do here is we're going to do 30, hit my cosine button, and it does match up with that. So what's happening here is we know that not only are these two angles going to be complements of each other, cosine and sines are complements of each other. So if that's true, then this should be the exact same thing. If they're complements, they should equal the same thing. So let's check that out. So we're going to do 45, and this I'm going to push the cosine button. Yep, and I get the exact same thing. So this tells me that this one must be this top one right here. And I'm going to try that again. So I'm going to do, what was it, cosine? So 15, hit the cosine button. We get this 0.966 when we round. All right, cool. And remember, so the cosine of one is going to be the sine of the other. So these two in the middle should match up. And just to prove it, I'll do it with the 30. I know I skipped the other one already, so might as well do it with the 30. And I'm going to do sine. And we see it does match up with, wait a minute. Did I do something backwards here? Hold on. Oh, angle B. Derp. We're doing angle B. So 60. Oops. Angle B is 60. 60 sine. Sine of 60. And it's going to be the same thing. So that I kind of derped on. We're doing of 60. So this one, again, these middle ones should end up being the same thing. What happened here? This is totally not supposed to be that. It's supposed to be 0.5. I don't know what happened there. But just to prove it, let's kind of do this. I'm going to do B is 30, 30, and I'm going to do sine. So I get that 0.5. And this is 15, so I'm going to do sine of 15. So clear this out. 15, I'm going to do the sine, and I get that point, well, sine, cosine. Oh my gosh, Victor, what's going on here? uh, 15, and I'm going to hit the sine. I am going to hit the sine button. What am I talking about? Oh, I messed up here. I kept hitting the wrong button. Why do I keep hitting the wrong button? So make sure you guys are hitting the right button for yours. What was this? 75 cosine, not sine. Yep, 0.259. At this point, I might as well just do all of them. I feel like every time I shortcut it, I keep messing up. So, which is a good lesson to learn, guys. Sometimes, if you're not paying attention to a shortcut, it ends up biting you. Do cosine of 45. Although this one, 45 degrees is the same across the board, so you don't have to worry about that one too much. This one should match up with that 0.866, but let me try it out just to be sure. So we're doing 30. We're doing the cosine. Yep, matches up, which means this one should match up with this 0.966. All right, so let's submit it. And we see my chart. They didn't get as specific as I did, but it should match up. It's just some round off error. Look at the definitions of the triangle, sine, cosine, tangent. Definitions. What do you observe from the previous parts support your explanation? The sine of A is always equal to the cosine of B and vice versa. This is because the adjacent of one angle ends being the opposite of the other. So what I'm basically saying here, I kind of explained it a little bit earlier, but it's this idea that if I have a triangle, oops, that this angle B, the opposite is actually the adjacent for the other. Oops, it should be an A, capital A. And then also, since B and A are complementary, the I see that the cosine and sine are complementary as well because plugging in the complement gives the same ratio. So what I'm basically saying here is if I plug in the complement, so when I plug in like sine of 15 and I plug in a cosine of 75, they equal each other. So that's what I was saying here, that these two equal each other. Because the cosine of 15 is equal to the sine of 75 and vice versa. So the sine of 15 is equal to the cosine of 75. What general conclusion can you do from complementary? State your conclusion in words in equations. Okay, so what basically what you're saying here, they just want you to use equations. So of A, sine of A equals cosine of and sine of sine of B is equal to cosine of A and vice versa. I don't want to type it again. And vice versa. And I gave a really big explanation on the other one. I gave explanation of this in the last answer. Right? Do that. And this one, oh, they do it with this. They're saying they're complements of each other. So they did it all fancy. They like officially went the complement of the other is equal to the complement of the other. Well, I guess for this one, I would give myself a 4. I did not realize they wanted me to use numbers to describe complement angles. And what I mean by that is instead of writing B, they're just saying sine of A and the complement of A. The only way to show complement of A is doing 90 minus A. So basically right here, this 90 minus A, 90 minus A, I kind of covered it, is a complement, complement, complement of A. All right, so I'm gonna submit this. And I don't think I've submitted. Yeah, I was like, I don't think I've submitted all of them. And I know I didn't because I have to click these. All right, I'm gonna go here. All right, and that's what they're just saying here is that these are complements. So angle A is 90 minus angle B, and angle B is 90 minus angle A. They're complements of each other. All right, so let's do this. If we have cosine or sine of A is this, then cosine of A or cosine of B, the opposite angle, opposite trig function, should end up being the exact same thing because we're looking at opposite over hypotenuse. So don't forget what your sine is, opposite over hypotenuse. So we can't really measure these, especially the hypotenuse. So they give you a picture, but that picture shouldn't really affect this answer. I feel like Edmentum gives you pictures sometimes when you don't really need them. All right, so this is saying that in which situation, what would theta be? So we want if we want the cosine and sine to be opposites or equal to each other, that means this has to be the complement. So in other words, what I'm saying here is theta equals 90 minus 58. It's the only way to do this. And luckily I didn't minimize my calculator here so I can just use this to help me out. 32. So I'm going to do 32 right here. Click done. And I got that correct. So that's what it means by sine and cosine are complements of each other. So again, summary, guys. Don't forget your SOHCAHTOA, and don't forget that the sine theta is equal to the cosine of the complement, and vice versa. Cosine theta is equal to the sine of the complement. Easy way to do it. So 2 short videos this week, guys. So hopefully that'll make an interesting Kahoot. We should be able to get a lot of questions in it. All right. See you guys.